guys. So we are now getting into the next module, module 8, and this is all about linear relationships and slope. And so the first lesson, lesson 8.1, we are going to work on proportional relationships and slope. As you can see, our learning target, I can graph and compare proportional relationships using words, equations, and tables, and interpret the unit rate as the slope of the line. There are a lot of vocabulary words that we are going to learn. Constant rate of change, linear equation, linear relationships, rate of change, slope, solution, and unit rate. Okay, so uh, look at proportional. What are proportional relationships? That's the first thing we need to look at. And two quantities are proportional if they vary and have a constant ratio or unit rate. The graph of a proportional relationship is a straight line and it passes through the origin. Okay, we have done this in the past, and now we are again touching this topic of proportional relationships. And linear relationships, and relationships that have straight line graphs are called linear relationships. Okay, so I have like drawn some on the this on the board just to make it clear. And proportional relationships can be represented using tables, graphs, words, or equations. All right, so just want to give you an example. So if you see what I have written over here in words, I can talk about it. A linear relationship is proportional when the ratio of y to x is a constant, which is m. All right. And the symbols over here, m is equal to y over x, or y is equal to mx, where m is the unit rate. All right. So now, you also need to know that m cannot equal 0. Okay, so m is the unit rate. Then the next thing, if I look at the table, there's a relationship that I'm showing over here between x and y. So you can see that if I'm looking at this relationship, if I do -1 times 3, I get -3. 0 times 3, I get 0. 1 times 3, I get 3. 2 times 3, I get 6. So we've talked about that y is the dependent variable, and it depends on what's happening to x. So as you can see, what's the relationship here between the input and the output, or the independent and the dependent variable? Y is equal to 3x, and that is just an example. And then let's if I'm graphing this, as you can see over here, I have -1, -3, 0, 0, 1, 3, 2, 6. So you can see it's a straight line, and that's why it's called a linear equation, and it is going through the origin. All right, and so that is why we had talked about this, that the graph of a proportional relationship is a straight line through the origin. All right. So let's talk about the rate of change. And a rate of change is a rate that describes how one quantity changes in relation to another quantity. And in a linear relationship, the rate of change between any two quantities is the same or constant. And this is called a constant rate of change. So let me make a table really quick so that you can see what I mean by that. And so I'm going to go ahead and show you that in this table over here that I have just drawn out, the time to download songs is shown in this table. Okay, so first and foremost, we need to see what is the relationship that is going on. All right, so if I look at the time in minutes, which is x, what do I see here and here and here? You can see that it is going up by 1. right? So that's why I've written plus 1 over here. Let's look over here. This over here, what pattern am I noticing? This is plus 2 and plus 2 and plus 2. All right. So as you can see over here that as the number of songs is increasing by 2, what is happening? The time in minutes is increasing by 1. All right. And so the unit rate is 2 songs per minute. So if I talk about the rate of change, let me just put that here, rate of change. Okay, if I talk about rate of change, this is over here change in songs. Okay, so it's going to be change in songs over change in minutes. Change in minutes. All right, so that is my rate of change over here. So you have change in songs over change in minutes, which is equal to what? 2 songs in 1 minute. 2 songs in 1 minute. And that is my rate of change over here. Okay. So now what I'm going to go ahead and do is I just want to show this to you, by actually graphing it. Because in proportional relationships, the unit rate is the slope of the line. And what is slope? Slope is the rate of change between any 2 points on the line. So let me first graph this. And if I have, this is my X, this is my Y. So my ordered pair is 0, 0. Okay. So this is 0, 0. And then I have 1 and 2. And then I have 2 and 4. So 2 and 4. And I have 3 and 6. Okay. And so here is my line going like this. It is proportional because it is going through the origin and it is a straight line. So it's a proportional relationship, and it's linear, as you can see over here. So if you want to look at this, it's going like up here, and then you have, so this is going up like this, and then from here to here, I'm going to do all the ups first, and then here to here, all the ups, and then you can see here. Okay, so I just wanted to show this to you. And here are my values. You have 0, 0 over here. You have 1, 2, 2, 4, 3, 6. All right. Now, let's look at this. What is the change in songs? So we can use the points. We can use any 2 points. But let's say I use the points 1, 2, and 2, 4. Okay, if I'm using the points 1, 2, and 2, 4 over here. Okay, so change in songs again. See, change in songs over change in minutes, and that's what we're trying to see. So what is the change in songs? It is the 4 minus the 2, because this is my songs. Okay, 4 minus 2 over change in minutes, which is going to be 2 minus 1. Okay, and so what do I end up with? I end up with 2 over 1, and that is nothing but the unit rate that we just talked about. Okay, so the slope is the rate of change between any 2 points on the line, and of course the unit rate is the slope of the line. All right, now let's go ahead, and I am going to take you to my whiteboard for an example. Okay, so let's look at this. All right, so the graph shows the amount of money Ava saved over several weeks. Find and interpret the slope, then find the unit rate and compare it to the slope. Okay, so let's look at this one. And to find the slope, we're going to find the constant rate of change. So we're going to find the constant rate of change. And what we're going to do is we are going to choose any 2 points on the line. So I'm going to choose this one and this one. Okay, you can choose any 2 points on the line. And then I'm going to find the rate of change between the points. Okay, so I'm going to find the rate of change between these points. And if I'm looking at the rate of change, we have the change in savings. Okay, so we have the change in savings, okay, over the change in weeks, over the change in weeks. All right, so when I do that, so let's see, what is this? Is money. So we have $30 minus 15. So this and this, okay, minus 15, okay, over here, this one and this one. So this is 2 minus 1 weeks. And we're talking about weeks over here. Right? So therefore, what is the change? The rate of change is going to be $15 because 30 minus 15 over 2 minus 1, that gives me in 1 week. And this is my rate of change, or the constant rate of change is $15 per week. And so the slope of the line is 15 over 1 or 15. This means that Ava saved $15 every week. All right. Now, to find the unit rate, what is the unit rate? It is the same thing, because where my denominator is going to be 1, so that means over 1, and that would be the unit rate. And so I'm getting $15 in 1 week over here. And so we are what is the unit rate? Ava say $15 every week. So the unit rate is $15 per week, which is also what? Which is also the slope of the line. So unit rate is the same as the slope of the line. Okay. Now, um, how would the slope compare if you had chosen two different points? So because the slope of the line is a constant rate of change, so what's going to happen? The slope is going to be the same no matter which 2 points are used. Okay, so no matter which 2 points are used, the slope is going to be the same. So let's do another one. And let's look at this example over here. All right. So the graph shows the relationship between feet and inches. Between feet and inches. And so there is my graph. And we are going to find and interpret the slope in this case. Okay. So what is the slope of the line? Again, I'm going to do the change, which is 24 minus 12, okay, which is the number of inches, over the number of feet, which is 2 minus 1. So I'm trying to find the rate of change, okay? And then I am going to look at what is 24 minus 12, which is 12 over 1. So therefore, we have 12 inches in 1 foot, basically. All right, so this is the slope. And the unit rate is 12 inches per foot, which is the slope of the line. All right. So let's do another problem about graphing proportional relationships. All right, let's look at this one. The distance y in miles that a certain cyclist can ride and the time x in hours are in a proportional relationship. This can be represented by the equation y is equal to 12x. Graph the equation and then find and interpret the slope. All right. So the first thing, of course, whenever we are doing problems like this, you are supposed to create a function table, okay, or relationship table. So in order, if you've got the rule y is equal to 12x, so if I create a table, okay, 3 parts, here we go. All right, we change this color, here we go. All right, so we have hours, which is x. All right, and then it says the rule is y is equal to 12x, and then we'll have the miles, which is y. Okay, and then let's have at least 3 points. So let's say hours is 0, 1, and 2. And what is a y? So we're going to just substitute the value for x. Y is equal to 12 times 0. Y is equal to 12 times 1. Y is equal to 12 times 2. And so what is 12 times 0 is 0. 12 times 1 is going to be 12. 12 times 2 is going to be 24. All right. So now after I have done this, I am going to graph the ordered pair. And so let me go ahead and create the graph over here. So we have time. And then we have this. So this is 0. This is my time over here. Okay, so since I've taken till 2, I would say this is time in hours. And so this is 1, 2, 3, 4. Okay, that's my time. And then I have distance in miles. Distance in miles. Okay, and let me just make intervals of 3. So 3, 6, 9, 12, 13. And 30. All right, and then let me use the red so that you can see better. So that's how I have made the intervals over here. This is the distance in miles, and we are talking about cycling. Okay, so let's graph this because we have, for 0, we have what? We have 0. Okay, so this is x, this is y. So here is my first point, which is 0, 0. Okay, my second point is 1 and 12. So if this is 1, this is going to be 12. Here's my next one. And then with 2, I have 24. So 2 hours and here's 24. Okay, this is 2 and 24. And then I just connect All right. And you can see that it's going as a straight line over here. And then what we're going to do is the interpretation of the slope. So in the equation of a proportional linear relationship, y is equal to mx, right? So y is equal to mx, or m, which is the slope, is y over x, right? So, or y is equal to mx. So m represents the unit rate or slope. So when the equation that has been given over here is where y is equal to 12x, all right. So basically, the equation y is equal to 12x represents the distance y in miles that the cyclist can ride in x hours. So the slope of the line is 12 over 1, or 12. This means that the cyclist can ride 12 miles per hour. So remember, slope is also the unit rate. So 12 miles per hour. Okay, so that's how we calculate this one. And how is the unit rate represented in the table, and how is the unit rate represented in the graph? So again, in the table, the unit rate is the constant rate of change. Okay. So look, this is going from 1, and 1 is increasing by 1, and this is increasing by 12, as you can see. So that is the constant rate of change. And in the graph, the unit rate, 12 miles per hour, is the slope of the line. Okay. So let's do another problem. Let's look at this one. So, an online music store charges $3.75 for purchasing 3 songs. Assume the cost Y in dollars is proportional to the number of songs X. Graph this relationship on the coordinate plane, then find and interpret the slope. All right. So once I have this again, part A, for this, I have 2 parts. I'm going to first graph the relationship, and then I'm going to make a table of values to find the cost for 1, 2, 3, and 4 songs. Okay. So let's find the unit rate first. So we have $3. We have $3.75 for how many songs? For 3 songs. For 3 songs, it is $3.75. Okay, change this color again to black. All right. So we are going to write it as a fraction first, obviously 375 for 3 songs, and then I am going to change this to a unit rate. So I'm going to divide 375 by 3, and I am going to get $1.25 for 1 song. So first thing is I have got to find out the unit rate. Okay, so the unit rate is $1.25 per song. After that, we are going to make a table. Okay, so number of songs. I'm going to make a table before I can graph it. So I have the number of songs, and this is X. All right, and then I have the cost in dollars, which is Y. Okay, so if I say I have 1 song, 2, 3, and 4, for 1 song, how much was it? $1.25. $1.25. Okay, so for 2 songs, it would be double that, or 2 times 1 and 2,500. I would get $2.50. And then for 3 songs, it would be $3.75. And for 4 songs, it would be $5. Okay, so first I create a table like this. And then after I've created the table, I'm going to graph the ordered pairs. So I'm just going to take you to the next slide because I've already graphed it over here for you so that it just saves us some time. Okay. So um, let's look at this one. So those were the ordered pairs that I created. For one song, $1.25. For two songs, $2.50. $3 for three songs, $3.75, and for four songs, $5. And then, of course, I create a graph where I have the number of songs, one, two, three, four, five, and then here is the cost, and I graph it. Okay, so once you've drawn this graph, here we can go ahead, and since you cannot purchase part of a song, that's why this dashed line is there instead of a solid line, because you've got to obviously get the entire song, right? So part B, we're going to find and interpret the slope. What is the unit rate? It is $1.25 for one song, and that is what my unit rate is. And so what is the constant rate of change? As you can see, it is going up by how much? It is $1.25 per song is the constant rate of change. And so the slope of the line is $1.25 over one song, or 1.25, or 1 and 2500. This means that the cost is $1.25 per song. Okay? Then let's quickly talk about comparing proportional relationships. You can use tables, graphs, words, or equations to represent and compare proportional relationships. Okay, so let's look at this one. So in the equation of a proportional linear relationship, y is equal to mx. M represents the slope or the unit rate. And in the table, the slope is the constant rate of change or the unit rate. And in the graph, the unit rate or slope is the constant rate of change or the constant ratio of y over x. And you can also find the unit rate from the point 1r, where r is the unit rate. Okay, so let me show this to you in words, equations, table, and graph. So if I pull this down, so look here. All right. So as you can see in words, what does it say? The cost y is directly proportional to the number of breakfasts, which is x. All right. Equation. So then before that, look at this also. Look at the table. It's showing me the relationship, what's happening. This is going up by 1, then the cost is increasing by 2, as you can see. All right. What was my equation? Equation is y is equal to 2x, right? Because 0 times 2, 0. 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. So you can see that y is equal to 2x. And then once you graph it out, this is what the graph is going to look like. Okay. So the number of breakfasts, and then this is completely 0, 0 over here, 1, 2, okay, 2, 4. So then it's graphed in this way. And just looking at this, you can find the slope. All right. Let's compare proportional relationships. So let's look at this graph over here. And here we go. All right, so let's look at this question. The distance y in miles that can be covered by a rabbit in x hours can be represented by the equation y is equal to 35x. Okay, the distance that can be covered by a grizzly bear is shown on the graph. Which animal is faster? Explain. So let's look at this. So this has given us, first we're going to find the speed of the rabbit. And if the speed is the unit rate, and what did we have? That over here, it was given to us that y is equal to 35x. All right, that is covered by a rabbit. So that is the first thing you look at. So the speed is the unit rate. In the equation, y is equal to 35x. The slope or unit rate is the coefficient of x. So the unit rate is 35 miles per hour, right? So this is the unit rate of the rabbit. Okay, next we're going to find the speed of the grizzly bear. In the graph, slope or unit rate is the constant rate of change, and the constant ratio y over x, or the point 1r. Okay, so let's look at this one. So what is over here? The change in miles over change in hours, right? So we have the change in miles over change in hours. Okay, so if I look at the change in miles, I have 60 minus, so this is my miles, right? 60 minus 30, and this is miles. Okay, over, then I look at the change in hours, which is this part. Okay, so 2 minus 1, and this is your hours, right? And so what do I get? I get 30 miles in 1 hour. 30 miles in 1 hour. Okay, so this is my grizzly bear, 30 miles in 1 hour. So we are going to use the constant ratio, write the ratio distance over time in simplest form for several points on the line. You can do 1 and 30, 2 and 60. So anyway, the distance over time is going to give me 30 over 1. Okay, so whatever you use over here. So you're going to get 30 over 1. So if you do 60 over 2, it is 30 over 1. If I do, so this is 30 over 1. This again, unit rate, 60 divided by 2, that gives me 30 over 1. Okay. So you're going to use the point 1r on the graph. The y coordinate is 30 when x is 1. So when x is 1, the y coordinate is 30, right? And then the point 1 and 30 represent the unit rate, which is 30 miles per hour. So using any of these methods, the grizzly bear travels 30 miles per hour. That's what the grizzly is traveling. And then you're going to compare the unit rates. The rabbit is 35 miles per hour. Grizzly is 30 miles per hour. So obviously the rate for the rabbit is greater than the rate for the grizzly bear because 35 is greater than 30. So we know that the rabbit is the faster animal. Okay? And then let's do one last problem. Here. Compare proportional relationships again. And the cost Y for computer repairs at Computer Access for X hours is shown in the table. Macro repair charges $23.50 per hour for computer repairs. Assume that the cost is proportional to the number of hours. Which company has the lower repair cost? Explain. Okay, so I'm going to show you the table because this is what we look at for this part. And there's my table. Okay, so we can look at these two over here. All right, so let's look at this one. And you have in the second the computer access, the number of hours, as you can see. What is the change? It is 1, 2, 3, 4, 5, and this keeps increasing by 25. So we are finding the unit cost for computer access. Because the relationship is proportional, the constant rate of change is the same as the slope and unit rate. So this is going to be our change in cost. All right. Change in cost, okay, over change in hours. Change in hours. Okay, there we go. All right. And so this is $25 in every hour. And that is what the change is. As the cost increases by $25, the number of hours increases by 1. So the unit cost is $25 per hour. And then from the problem, we know that macro repair charges $23.50 per hour. So look this one. All right. And so the rate for repairs at macro repair is less than the rate for repairs at computer access. And since $23.50 is less than $25, macro repair, this one, macro repair has the lower repair cost. Okay. So once again, this lesson is all about your proportional relationships and slope, and you are graphing, comparing proportional relationships using words, equations, and tables. And then, of course, looking at that, then we can interpret the unit rate as the slope of the line. All right. Have a great day, everyone.